Thank you so much, sir, for such an outstanding and knowledgeable session. Now, I would like to call upon Om on stage to felicitate our speaker.
पीपीटी दिलेली आहे केले सर ये मध्ये अभी चालू झालं की घ्यायचं आहे मध्ये कोणी म्हणा का फक्त
Moving ahead, please welcome our next speaker, Mr. Abhishek Wagh, who will now give a lightning talk on Karpenter Chronicles, revolutioning Kubernetes workload scaling strategies. He is a platform engineer. He is a AWS certified and possesses experience in designing, developing, and deploying scalable and reliable solutions. Please welcome Mr. Abhishek Wagh with a hearty round of applause.
Guys, this is the feedback form for our user. Please scan it and provide your feedbacks.
Okay, I hope it is done, so I'll just stop sharing. Okay guys, so our next speaker, he is a young enthusiast, and not just a young enthusiast, but he is the organizer for AWS UG Nasik. He has been the speaker for various community days, including Hyderabad and Pune and so on. So yes, please give him a round of applause once again. What do you appreciate?
Hey, hi folks. I hope my voice is audible till the last, right? Yep, thank you. So I won't be taking much of your time. Basically it's a lightning talk, so I'll try to highlight whatever I have in quick manner as possible. So my topic for today is, as you can see, Karpenter Chronicles. Who all of you have already worked on Kubernetes or container ecosystem? Yeah, and anybody already used Karpenter by any chance? Okay, I have a few hands as well. Okay, so basically before starting, I'll a short brief about me, as already our host has mentioned. So myself Abhishek, I work as a platform engineer. I handle DevOps and platform related stuff at Quantify, and I am also a fourth year running AWS Community Builder since the inception of the program, and I lead AWS User Group Nasik. As Rahul sir already mentioned in his talk, like how tables have turned. So you might have seen me volunteering since morning today, but yeah, I'm presenting in front of you right now. So yeah, that's a little bit about me, and here's our quick agenda. So first I'll be quickly walking you guys through the Kubernetes and resource scaling, a small intro about that. Then the auto-scaling landscape, how Kubernetes pods and nodes are auto-scaled automatically. Then some of the limitations, advantages, pros and cons, then group-based auto-scaling. Demo I won't be able to show due to time constraints, but yeah, definitely I'll be more than happy to talk outside. And yeah, we'll conclude then. Okay. So to get things start, I think most of you already know, like there are two types of scaling in cloud overall when considering platform. So which is horizontal scaling and vertical scaling. So in horizontal scalings, you add more pods basically and increase the instances of the application. And in vertical scaling, you basically add more compute resources such as EC2 servers or auto-scaling groups, which in turn runs your application workload. So this is the difference between scaling. And yeah, as I mentioned, pods, nodes. If some of you are students and do not have any experience on Kubernetes, so I'll quickly brief about it. So pod is basically nothing but your application instance which is running already on a node, and node you can consider as a server. So for example, here I am taking EC2 instance, which we are considering nodes today. As mentioned in the PPT, pods is the smallest execution unit of your application. Node is an instance to run on which the pod runs. So it might get confusing on the side, but yeah. And I think storage and network you already know for the application. Then yeah, so first of all, before scaling pods, so from where these pods come, how they are deployed. So there are few ways. So like in this slide, it is mentioned like we can create deployment set, then the replica set or stateful set, daemon set, such as deployment creates a overall instance like whatever mentioned resources, IP addresses, elastic IPs, whatever you load balancers. So overall the configuration is called as deployment. And replica set is nothing but a tool which can manage at the same time how many pods or how many nodes will be running at a time. So yeah. Then to scale the pods, basically there are multiple tools available in the market right now. Some of them are third-party tools such as Knative, then horizontal pod autoscaler and vertical pod autoscaler. So these are few tools using which pods can autoscale. But scaling the nodes, basically the server, how we scale it, it is a actual problem we are solving here with Karpenter. So either you have to manually upscale or bump up your server while your application is running, or you can use a cluster autoscaler, which is known as CAS also, if some of you might use the shortcut. So a little bit about cluster autoscaler. What cluster autoscaler solves actually. So cluster autoscaler is industry standard for Kubernetes applications before the Karpenter existed, and it is open source, vendor neutral. You can use AWS services, you can use GCP services, Azure, whatever, using the autoscaler, cluster autoscaler or CAS. And it is already tested for various, as I mentioned in the sheet, like it's battle tested up to 1000 nodes. It can run almost 1000 nodes at a time, and it can increase to 30 pods per nodes. So it's pretty good. Then it uses existing cloud building blocks, such as on AWS, if you want to scale EC2 server, you either use autoscaling groups. You can manually increase the server, but you'll again have to apply the configuration on the same, right? So usually we use autoscaling groups. I personally use autoscaling groups in my projects and my day-to-day work. There are some challenges with CAS, which is you have to manually prepare a combination, because if EC2 is there, if you consider EC2 has a lot of instance types such as T2 micro, T2 medium, then 2x large, lot of variants and combinations. It has multiple AZs, then there are labels, tags, various resources to manage. So so CAS is not that smart at the moment, which it can intelligently capture what is the requirement of your application based on the load it is running on, and it is, as you can see, it is tightly bound to the scheduler of the Kubernetes, which comes in stock. A small example to explain whatever I talk. So you can see at the extreme left there are some pods which are in pending state. Okay, so you can see there are 2 pods already running on a node. Node is nothing but a server, and 2 pods are already running off the application instance. But you can see below that there are 2 pods waiting to be run, because the load is coming to the application, and we have to scale it. So what the CAS will do is it will try to invoke the cluster autoscaler. It will provision the whole node. You can see whole new server is provision, and all the remaining 2 pods it will schedule in the new node. But if you see, there are 2 servers created by autoscaler, but if you see in each of the server, each of the node, there is one space is remaining still. Okay, so that is what cluster autoscaler is not able to understand, like if it should increase the node size, which I will talk about when I go to the Karpenter slide. But I hope this clears a picture a little bit. Yeah, now coming to the Karpenter project. So Karpenter is basically a autoscaling tool which is incubated in AWS labs. They have open sourced it for its Kubernetes solutions, which is EKS, and but it is also vendor neutral. But at the moment, it is bound to AWS because it is pretty new. Like I think last reInvent it got announced and made generally available, if I am correct. So it directly provisions capacity. So as you can see in the last diagram, cluster autoscaler had to create a new EC2 server, which Karpenter won't need because Karpenter directly manages nodes and not pods. So if you can see, it removes the node groups concept. It actually provisions a whole new capacity, which manages existing nodes as well as upcoming pending nodes. As you can see, that is why it is called as groupless node autoscaling. So there is no grouping involved. It totally creates a new node or new machine or new server in runtime, just in time, which we call it in the industry. And as an effect, it removes the cloud provider API utilization, because we are not constantly polling the API to see what is the load on our application, then how we can increase the nodes, and in turn the pods if the nodes are not sufficient for our application to run. Then it reduces the configuration complexity, because as I mentioned, it is smart enough to understand what the capacity it needs. So yeah, so this is another diagram which I have prepared. So on the extreme left, again the same scenario but using Karpenter this time. So at the extreme left you can see there are pending pods, which are there are pods which need to be scheduled somehow, but this time we are using Karpenter and not CAS, which is cluster autoscaler. But if you see existing capacity, there were two servers already there because two nodes were there, and then you can see unscheduled pods. So there is some traffic which is incoming to the application through the load balancer, and you want to schedule all those pods so that your traffic gets properly served. So for that, there is this term, as I mentioned in the last slide, which is just-in-time capacity, and you can see in middle Karpenter. So Karpenter is smart enough to understand. What it did is, rather than having 3 servers, it created one big server and it added all those unscheduled pods to the server, and remaining one, which were 2, it created a reasonably small size of the node, and remaining pods it scheduled there. So this is what the main difference between the autoscaler and the Karpenter. So yeah, the conclusion and takeaways from this session would be that capacity planning is literally hard. So you have to, before you launch your application, you have to plan for how you will autoscale it when the traffic induces lot than regular, and you have to keep in mind that how your application would respond to it. Would it be sufficient, or is there pros and cons you have to balance, and then you will have to take the decision. So the key advantages of it is like it is flexible, lowest complexity, portable for the obvious reasons as I mentioned in the previous slides, and even if it's smart enough, as I mentioned, to do all those stuff, to understand how much compute capacity it will require, it provisions all those resources within a minute, so the latency is very less. And as I mentioned, so there are some cons. Currently supported provider is AWS, then it doesn't support spot instances. Fargate, I guess, also not supported, only EC2 instances it supports at the moment. And at the very last, there is the Karpenter website. I'll try to show. Anyway, just to save time, you can see on the slide itself below karpenter.sh. You can go there. It is a pretty vast documentation, and there is a getting started guide as well. If you want to quickly spin up your instances, quickly spin up your application through Kubernetes, you can quickly go to the site. It will be a guided tour. You can properly set up and understand how this is working behind the scenes as well. And yeah, I think that would be pretty much it. Thank you so much for your time. And I let you go to the break. Thank you so much. Just before stepping out from the podium, I just wanted to mention that thank you so much. As I mentioned in the start, as Rahul sir also mentioned, how tables have turned for him. I'm also volunteering here. I'm volunteering since past couple of years for the community days, and I'm getting to present here in front of you guys, and you guys being patient and understanding me and listening to me. I appreciate it, and thank you so much. One last thing, if you are still interested in more community days, because the day is getting to the end, there is an AWS Community Day Nasik which is coming up at 29th of October this month. If you guys are interested, reach out to any of us and we'll be happy to help. Thank you so much.
Thank you for such an amazing session. Now I would like to call upon Pushkar on stage to felicitate Rahul Gaikwad.
Abhishek Wagh.
Okay, it is really proud to see the co-organizer Nasik felicitating the organizers of Nasik UG. Okay guys, thank you so much.